Long before forests stretched across continents, before birds, mammals, or even dinosaurs walked the land, Earth was a silent, barren world. There were no towering trunks, no rustling leaves, no shade, just rock, water, and wind. And yet, hidden within this lifeless landscape, something extraordinary was beginning to emerge. The first forests on Earth existed before what we would even recognize as trees. To understand this lost world, it helps to imagine a time over 400 million years ago, during the Devonian period. The continents were arranged differently, clustered in fragments rather than the familiar shapes seen today. The climate was warmer, the atmosphere richer in carbon dioxide, and the land itself was almost entirely devoid of life. But at the edges of rivers and shallow wetlands, the earliest plants had already begun their quiet invasion. These were not trees in the modern sense. They had no true leaves, no deep roots, and no complex branching systems. Instead, they were simple, upright structures, thin, spindly stems that reached upward, sometimes only a few centimeters tall, sometimes stretching to a meter or more. Early plant groups, such as Cooksonia, are among the first known examples. Fossil evidence suggests these primitive plants lacked leaves entirely, relying instead on their stems to carry out photosynthesis. Despite their simplicity, these early plants represented a massive shift in Earth's history. For billions of years, life had been confined to the oceans, but now, for the first time, organisms were establishing a permanent presence on land. Scientists believe this transition required extraordinary adaptations. These plants had to resist drying out, anchor themselves in unstable soil, and transport water internally without the complex vascular systems found in modern flora. As time passed, evolution began to accelerate. Plants grew taller, stronger, and more complex. One of the most important developments was the emergence of vascular tissue, internal structures that allowed water and nutrients to move throughout the plant. This innovation changed everything. It allowed plants to grow vertically, reaching higher towards sunlight and spreading across wider areas. By the middle of the Devonian period, around 390 million years ago, something remarkable had formed: the first true forests. But these forests would look alien to modern eyes. Instead of leafy canopies and dense undergrowth, these early forests were dominated by strange, unfamiliar forms. Among them were towering plants like Watieza, which could grow up to 8 meters tall. Despite their size, they were not true trees by today's definition. They had no leaves, but instead bore frond-like structures at their tops, somewhat resembling giant ferns or palm-like crowns. The trunks of these plants were thick and fibrous, but they lacked the wood found in modern trees. Their internal structure was simpler, and their support systems relied more on outer tissues than dense inner rings. At their base, instead of deep root systems, they often had networks of shallow anchoring structures that spread outward across the soil. These early forests were sparse compared to modern ones. Sunlight would have easily reached the ground, and the spacing between plants created an open, almost surreal environment. The air was still rich in carbon dioxide, and oxygen levels were rising slowly as plants continued their work. But even in this primitive state, these forests were reshaping the planet in profound ways. One of the most important changes was the formation of soil. Before plants, land surfaces were largely bare rock, but as these early plants lived and died, their remains began to accumulate. Combined with weathered rock and microbial activity, this created the first true soils. This transformation allowed more complex plant life to take hold, accelerating the spread of vegetation. At the same time, roots, still evolving but becoming more advanced, began to break apart rock surfaces. This process, known as biological weathering, played a critical role in shaping Earth's landscapes. Rivers changed course, sediments shifted, and new ecosystems began to emerge. Perhaps even more significant was the impact on Earth's atmosphere. As plants absorbed carbon dioxide for photosynthesis, they gradually reduced its levels in the air. At the same time, they released oxygen as a byproduct. Over millions of years, this slow but steady process helped transform the planet's climate. Scientists believe the rise of early forests may have contributed to global cooling. By pulling carbon dioxide out of the atmosphere and locking it into plant material and soil, these forests could have triggered changes in temperature that affected the entire planet. Some researchers suggest this played a role in the late Devonian extinction events, although this remains an area of ongoing study. As forests continued to evolve, new types of plants began to appear. Lycophytes, horsetails, and early ferns spread across vast swampy regions.
These plants developed more complex structures, including true roots and leaves. Over time, they would give rise to the dense, humid forests of the Carboniferous period, where giant plants formed thick canopies and vast coal deposits. But the earliest forests, the ones that came before trees as we know them, remained unique. They were transitional ecosystems,